Hi, my name is Chandni and I am from the curriculum team. Students learn addition algorithm in grade 1. For example, if they have to add the numbers 37 and 48, they will first arrange the numbers vertically, then add the ones to get 15 at the ones place, carry over this additional 1 to the tens place and get 8 at the tens place, and hence the result as 85. Do you think most students know why does this algorithm work? I don't think so most of them do. At Cuemath, the reason why the algorithm works is as important as the algorithm itself. A Cuemath student learns and sees 37 as 3 tens and 7 ones, 48 as 4 tens and 8 ones. Let's try and add these numbers visually. The beads on the units wire add up to 15. Put 5 of these beads on the units wire. Combine the remaining 10 to form one single tens bead. Now add this one bead to the tens wire, which already has 3 and 4 tens beads respectively. Thus the obtained answer as 8 tens and 5 ones, that is 85. So you see, this additional carryover of 1 is nothing but a 10 being generated, and students must know this. At Cuemath, the focus is not only on the how but also on the why. Some time back, we did a survey of students who had studied decimals at their school. We asked them a simple question: which number is greater, 0.19 or 0.2? Surprisingly, most of the students answered 0.19 as their answer, as it had number 19 in it. At Cuemath, students learn decimal in a very different way, through visual modeling. Let's take this 10 into 10 grid or flat and call it 1 unit. One rod of this flat is 1/10th of the flat. It can also be written as 0.1. One block of this flat is 1/100th of the flat, which can also be written as 0.01. Let's take a collection of 2 flats, 3 rods and 4 blocks can also be written as 2.34, or the number 1.03 can also be represented as 1 flat and 3 blocks. So going further, we ask the students again 0.19, which is 1 rod and 9 blocks, and 0.2, which is 2 rods, which number is greater? Now looking at the two representations, it was much easier to answer. Students learn in middle school that the area of a triangle is half base into height. All that they do is learn the formula and never know the reasoning behind why the formula works. All that they are made to do is learn the formula, ending up with a very superficial understanding of the concept. At Cuemath, we believe that math is beautiful and that every child can fall in love with math. Let's consider an example. If we draw a rectangle with the same base and height as the triangle, the left half of the triangle is same as the left half of the rectangle, and the right half of the rectangle is same as the right half of the triangle. Now, hence the area of triangle is half of the area of the rectangle. But what is the area of the rectangle? It is base into height, and thus the area of triangle is half base into height. We often tend to think math is all about numbers, calculations, formulas and theorem. However, Cuemath has a holistic approach towards math learning. An interesting aspect of the learning program is the non-verbal skills based on pattern recognition. Let's consider an example. Here, the student has to figure out the next item in the series. Solving this involves identifying the pattern of rotation from one item to the other. The rotation pattern here is that of clockwise rotation of 45 degrees. Let's consider another example. Over here, the student has to complete the missing figure using the given options. Now, doing this would involve a fair understanding of symmetry and reflection to reconstruct the missing piece and complete the given figure. These are very important mathematical skills that a child must know and should develop. Many individuals are great at math and they attribute their solving abilities to solving puzzles at a very young age. Solving mathematical puzzles or any type of puzzles involve mathematical reasoning, which is in itself a very sophisticated mental skill. Take this simple puzzle which even a very young child can understand. For example, if numbers from 1 through 10 are placed in a row and you have to put a plus and a minus sign in between these numbers such that the resulting expression is that of a 0. Most adults and even children try this by trying out various combinations of plus and minus signs. However, they end up saying that it is possible to add up the numbers to 1 but not possible to add up the numbers to a 0. The answer to this problem is doing this is not possible. But even more interesting part is, why is this not possible? Why can't we make a 0? Note that sum of all our numbers is 55. Now let's put plus and minus sign between these numbers. Collecting all the positive numbers and the negative numbers will give us one positive number and one negative number. It is important to note that these numbers do not add up to 0, or any combination of it will not add up to 0. Also, 55 is a number which cannot be divided into whole number parts of the same magnitude, and hence the answer can never be 0. Get it? Reasoning like this is what math is truly about. Reasoning like this can make a child fall in love with math. Reasoning like this is fundamental part of Cuemath. We hope that you like this introduction to Cuemath's learning methodology. Visit cuemath.com to know more about our program and an evolutionary style of learning. Thank you.